You can use it for doing deep linking into your app. You can use it for communication between apps. It's pretty cool. So we talked about activation. One of the other main strata that I think about when I'm starting an app, before I've written any code, is the fact that I need to think about the way that the system works with regard to suspension. So there's this thing in our system called process lifetime management. And the idea is that you can take a Surface class tablet, which is, by modern standards, not a super powerful machine. It's not my i7, laptop. And you can have an app in the foreground that's just shining, and the apps in the background aren't taking up a lot of memory, aren't taking up a lot of battery, things like that. And so what the system does to enable that is a bunch of stuff. But one of the things that it does is when apps go into the background, after a period of time or if resources are needed, those apps will be suspended. And when those apps are suspended, what happens is they get a message from the system saying, you're suspending now, you should save any state you need to save. You get a period of time to do that. And then the app gets put actually into a suspended state where it's not running, no CPU resources at all. Eventually, if the system needs those memory resources, that app may be terminated. But later, when the user goes to switch back to the app, they'll swipe in from the left of their screen. And the expectation that the user had is they didn't close that app, so it should be running the same as it was before. Now, that unfortunately means that as an app developer, you have to worry about this from the beginning. If you want to have that great seamless experience, you're going to have to save state in suspension, and you're going to have to be able to restore it when you get activated from that terminated state. And so the checkpoint handler in WinJS.ApplicationObject is the place to do that. This is the handler that gets called at suspension time, and you have the opportunity to save whatever state you need to save. And the idea is that from the beginning, you're thinking about this so that you can build an app that comes back well. One of the things to remember is that resuming from suspend is different than resuming from termination. So resuming from suspend, when you went to the background, you got suspended, and then you weren't actually terminated, but you came back, you still have all your memory in place. It's really just like you got switched off the processor. Resuming from termination is a brand new startup. And so you actually have to worry about how do you get back to the place that you were. So one of the things that you can use to help you get there is this WinJS application session state guy. So we give you one little helper, and it's an object that you can stick stuff into. And as long as that stuff is JSON serializable, then when we suspend, we will save it for you. And when you resume, you'll get it back. And our recommendation, and you can see this in some of the VS templates, is to save things like your navigation history stack in there. And on resume, you restore your navigation history stack and navigate to the tip. One of the pro tips here is if you build an app that deals with suspend and resume well, it turns out it'll probably deal with navigation well too. And so that's one of the reasons that I like thinking about this from the beginning. One of the other things that you have to deal with in Windows apps, like any app, is exceptions will happen. Unfortunately, versus the web, the Windows 8 app host is less forgiving. So in the web, a lot of times something can go wrong and the page can continue rambling on. And so you've all visited web pages where the Flash player is just showing an empty box, or sometimes even the JavaScript host has given up because it's Stack Overflowed, but you can still read the content. Well, Windows 8 apps are all about interactivity and responsiveness, and unfortunately, in order to do that, or fortunately, depending on how you look at it, you have to have that JavaScript app host running. So we had to enforce a slightly higher bar. And so the bar that we end up enforcing is any exceptions that escape from your event loop end up terminating the app. And that's a great thing because you'll actually get stack traces and you'll get dumps. They go up to the store. You can go as an app developer and get them, and you can see how people are crashing in the field and try to figure it out and fix it at home. But it does mean that you're going to have to deal with this kind of from the beginning. It's less forgiving. And so the WinJS application on error event is where we route all those in the WinJS app model. And you'll find that is the place that these exceptions come into, and that's the place where you have the opportunity, if you want to say, hey, you know what, I don't really care. I'm gonna ramble on, and the JavaScript host will be up, but I'm gonna ignore that exception. My app may or may not be in whatever state. Or you can have enhanced logging. You can shoot some diagnostics back to your server, whatever you want to do. So that was how I think about structuring an app. Now let's move on real quick to navigation. So one of the things in a web browser is that you have navigation built in. You have the location object. The web browser has a bunch of Chrome for it. You have back and you have forward and you have a location bar. And people think about navigation as a first-class thing. You have bookmarks. Inside of an app, we don't have that built in. Apps are meant to be self-contained little entities, and they have the ability to communicate with other apps through these contracts, like the protocol handler we saw before. But we do believe still people want to build these apps that have these navigation concepts. And you can see that in a lot of the apps, for instance, that are in the box. Things like the Photos app and thing. And so normal browser navigation isn't supported. And the reason for that, or it isn't our recommended way of doing navigation in Win8 apps. We recommend you build more of a single-page application-style app, which you can see on the web today in things like Gmail and OA and a bunch of other stuff. We were calling them Ajax for a while, but
that's not hip enough.
That's not hip
enough.
No.
Now it's SPA. It's got to be an acronym.
But so in order to enable that, in order to enable not losing your script context as you go from place to place, we provide a simple navigation utility in WinJS. We provide basically a history stack that has like back and forward functionality and the ability to navigate. And the expectation is developers like you will end up building an appropriate navigation scheme on top of that. So the WinJS navigation namespace, like I said, offers functionality like back, forward, and navigate. And it turns out we built one more thing that dovetails very nicely with this, which is the WinJS UI Pages framework. And so the Pages toolkit is all about taking HTML, JavaScript, and CSS, that's kind of one little component, out of your AppX package and loading it into the application. And this allows you to design it separately. It allows you to dynamically load it so you don't have to pay that cost at startup and do a lot of things like this. And it works well with the navigation model. So now Chris and I are going to build the simplest navigation that we can.
Absolutely simplest. No creativity involved.
Well, there's going to be, yeah, we'll see.
Anyway, great.
All right, so.
We are where we left off?
We are where we left off. So what should we start with, Chris?
I think we should start with listening to our navigation event.
All right, so let's go back to our JavaScript. And so we're going to go up here. We have our aliases. I talked about the app alias before. Let's add the nav alias. So it's just WinJS.navigation. And then we'll go here and we'll add nav.onNavigating. So there's 3 different navigation events that are for different scenarios, like being able to cancel navigation and stuff. A bunch of samples online about that. And so in here, the args object will give us 2 things that are of interest. One is args.detail.location, and the second is args.detail.state. And we're probably just going to use location here, but it's interesting to note that we built this model so that our history stack for any given level in the hierarchy, any given level in the navigation, can have both a location object, which can be whatever you want, and then a state object that you can pass around. And the idea is that you serialize those when you suspend, and you bring back and use those to rendezvous. So now we're going to use our Pages framework, our Pages toolkit. So WinJS.UI.pages.render, and we're going to give it that location. And we are going to render it into somewhere. Where are we going to render it?
Somewhere. We'll go make something to put it in a moment.
All right. And we're going to give it those options as state.
Okay.
So now if we can go make somewhere, we'll go back to default.html. We'll make a div, and that's where we're going to put this stuff. All right, pretty cool. And now, okay, we're going to style it. Great.
And we probably want to clear this out each time.
Probably want to clear it out each time. So now what do we want to navigate into? So let's make a couple of pages. So WinJS.UI.pages, like I said, is about these kind of groups of JavaScript, HTML, and CSS. But for the simplest case, we're just going to have 2 empty HTML pages. So we'll have page.html, we'll copy it, and we'll make page2.html. And Chris will nicely put some content in here, and we'll put links to each of the pages. Ignore page 1. Thank you. All right. So here's page 2.
Okay, and then page 1.
Page 1 is going to be pretty much the same thing, I assume. And then the last thing we'll have to do after Chris stops typing is we'll go back into our activated handler and we'll navigate to one of them to start, just so we can get some content into our app.
Great. So we should
go in
default
here.
navigate.
And so in our activated handler, we will call nav.navigate. And we will pass it the URI, which is a package relative path. And let's run. All right, so this is the best page. Page 2 is bad. And so what happens when you click on, that isn't what I wanted. Why didn't that do what I wanted?
I think that was an A tag.
Oh.
And that actually did browser nav.
But we don't want browser nav. We want to save the script context. We want to be cool.
Yes,
right?
in fact.
SPA app.
Yeah, it's fairly broken now.
All right, so what do we have to do what we wanted? I think what we need to do is we actually need to call the navigate method. So we just put A tags. And so in your app, you'll use buttons with on-click handlers, or you can do what we're about to do here. And so I think what Chris we should do is we should just go through here. And after that page has been rendered, so this is our first little insight into promises here, the then method. We'll talk about that a little bit later. After our page has been rendered, we're going to use our query utility. we're going to go find all the A tags in somewhere, and we're going to listen to their click handlers, and then we're going to call nav on them. And so we'll just go in here, and we'll say nav.navigate of e.sourceElement.href, I think, and then we will call prevent default to keep them from doing the normal navigation. So now, in theory, hey, we can go back and forth.
And we keep that state around so we can see the little calc running at the bottom.
That's pretty cool. So, but we already built a protocol handler. Couldn't we build deep linking now?
I think we could.
Okay, let's go build deep linking.
Awesome.
So, what do we need to do? I think all we need to do probably is change our protocol handler. So let's take our protocol handler, and instead of echoing the result of our world's best calculator, it's called nav.navigate of URI.path. All right, and now let's, what are we doing here? Oh, okay, great. So we'll change this to calc/page 2. Probably change the text that we're going to click on. Let's see it. Hey! And so in theory now, we can go to the run dialog like we did before. And we can say calc page 2.html, and hey, that's pretty cool.
So that's if you've used the App Store, the fact that you can go to the App Store and you can get links from your web browser that go into the App Store and show you the description page for the app. If you go to music, you can get links to music. All that stuff runs through these protocol handlers in the systems. So you can see that you can really build an extensible system. You can plug into the protocol handler, do your own navigation, and really kind of have a rich data model associated with your app.
That's pretty cool. Can you switch them back? All right, so we built the simplest navigator we can. There are all kinds of navigation schemes that you may want to build for your app. We actually built one into the VS template, so if you use the grid template, the split template, or the navigation template, you'll find that you'll get a file in there called navigator.js, which handles some of the things for you that you might want to handle, or you might want to do different things. One of the things it handles for you is animated transitions between pages, so when one page comes in, it does a enter page animation using the PVL animations that we ship in the WinJS library. Another thing it does is it hooks events like Alt-Left and the back button on your mouse so that when the user is in there navigating through your app, they kind of have a familiar experience that you would expect in a world with navigation. It also gives you the facility for the little back button that you have, and you see that in the templates today. My message to you today is just don't be afraid to customize that. The Page Control Navigator is a place to start. And I think it's a fine place to start, but there's plenty of other things that you'll want to do in your app. You know, you may have a hierarchical app where you actually do want to pull things out of the DOM, or you want to just hide them when you navigate from page to page, so that when you navigate back, it's like instantaneous nav. Whereas the Page Control Navigator, the way it's built today, is kind of for more of a linear navigation, and you obviously wouldn't want to keep all those things in memory because it can become infinite. Great. So that's kind of navigation.
Deep breath. We saw structuring an app.
Yes.
We played around with navigation.
Yes.
One of the big things. Now, probably, I don't know, this is Josh's favorite feature. Josh wrote our promise implementation twice.
I'm sorry.
He liked it so much he wrote it twice. And this is one of probably the biggest areas in terms of questions we normally get is promises and asynchronicity in the WinRT and how to program against these effectively.
Yeah, so promises. Win8 apps are a highly asynchronous environment. One of the things that we decided we wanted to do from the beginning was have a very responsive system. And the JavaScript and HTML environment was another thing we wanted to do from the beginning. Well, the JavaScript HTML environment has one thread. Count them. One thread. And that one thread needs to yield periodically so things like input events can happen, like scrolling events or click events, things like that. And so if you end up like just pounding on that thread for 500 milliseconds, and the user clicks on your app is going to feel dead to that user. And so we said, okay, great. We're going to make a kind of by fiat, we are going to have no APIs in the system that take longer than 50 milliseconds. And if those APIs take longer than 50 milliseconds, they're going to be asynchronous. And this ended up with a lot of asynchronous APIs. So for a while, we had callbacks and things like that. And then we decided we really needed a mechanism to compose these things. It turns out if you've ever used C#, a couple releases, a release ago, ended up with Task of T. And so they have a composition mechanism for asynchrony. And they have the async feature now in the C# language, which is a pretty cool feature. We ended up going with a different version of kind of the same thing. You know, promises, it turns out, as a computer science thing, have been around since probably the 50s and 60s, like every other computer science thing.
There is nothing new.
There's nothing new. But the current thing that's gaining a lot of traction on the web today, and was a couple years ago when we committed to it as well, is the CommonJS Promises A spec. And you see implementations of this in jQuery, you've seen implementation in Dojo, you've seen people in Node.js use it. And so we got on that bandwagon, and we have an implementation of Promises A as well. And we use that throughout WinJS for all of our asynchrony, and then we also put it into the platform. So if you know how the JavaScript, the Windows runtime methods are projected into JavaScript, the way it works is there's a WinRT COM-based interface, and then the JavaScript engine, Chakra, actually projects them into JavaScript. And all the async methods there, it turns into promises as well. And the neat thing about the CommonJS Promises spec is it actually says very little about your implementation. All it says is you have to have this unified contract. And as long as you have this unified contract, you can compose these promises from different systems very, very well. And so it's pretty cool. Now, asynchrony in general and promises specifically are very easy to use initially. They can get quickly very, very complicated. So we're going to write some code today here on stage to wrap XHR in a promise. It turns out that the jQuery guys have an implementation of this. Their XHR implementation returns a promise. Turns out WinJS also has an implementation that takes XHR and returns a promise. And we're going to build another one here on stage today because obviously that code that we tested and shipped wasn't good enough.
Not good enough.
So great. So we're going to build a function that's going to take get, and it's probably going to take a URL.
Whatever.
And so this guy is going to do that. And the first thing he's going to do is say return new WinJS promise. So promises have two sides to them. In the web community right now, what's happened kind of since we made this decision a couple years ago to go with this is they've started using a different name for one side of them, which is deferred. And so when I say new WinJS promise, if you have your jQuery hat on, you might recognize deferred as a terminology. Conceptually, that's this side of promises. The other side of promises is the then method, which is the consumption of promises. So right now, we're going to build a new promise, and so it's kind of like deferred. So we're going to say return new WinJS promise. It's going to pass us in a couple of functions that we can use to complete that promise. So the C is when we complete it when we're done successfully. The E is for when we're done with an error, and there's a progress guy. We're not going to use that today, but you might use that in an API. Now, what we've done here is we've created a promise that will never complete, which is not
awesome.
It's awesome.
We could all sit here and wait for a really long time while we do an event on it.
Just like take a deep breath.
Yes. This is my machine is so fast it can solve infinitely hard problems.
Yes.
Yes.
Infinite loop in 13 seconds?
Yeah.
All right. So, but what we're going to do here is we're just going to return right now some value, like complete of some value. There we go. And so now, just so we can show how this works, let's go say winjs.utilities.ready, just so we make sure we're after the DOM's all been loaded and things. And we'll say get of some URI, maybe bing.com or something. Now, of course, this isn't going to go to bing.com because we're not actually doing anything here yet. But we'll say then, and we'll get a value back. And that value is the value that we passed into the complete handler. And now we'll just echo it back to the screen. So can we run that? And there you go. There's some value. It worked. It was like magic.
It is like magic.
It was like a function that called a function that called a function.
It is the most complex way of calling a function that I've ever seen.
It's a pretty complicated way of calling a function. But let's call something that's actually asynchronous, like XHR. So we'll say new XML HTTP request.
I'm going to put it in a variable.
All right, that'd
That's
be a
just
good
me.
thing. Great. Microsoft's contribution to Ajax right here. So request at open, we'll say get of our URL. And then we have to say request at on ready state change. And so the way XHR works for anyone who doesn't know is it runs through a little state machine, and you get this ready state that counts up from 0 to 4. And once you get to 4, you are done. So if inside of our function, we'll say if request dot something. What is it?
Ready state.
Ready state. If request dot ready state does not
our
equal to
API.
4, and then we'll say we need to look at the code, the status code that is returned from the HTTP server. So, we're all very familiar with 404s and things like that. All the status codes in the 200s we're going to treat as success. So we'll say if status codes between 200 and 300, then we're going to call the complete handler, and we're going to call it with the response text, just for simplicity's sake. And then we'll say if it's any other, we've gotten to ready state 4, it's any other status, we'll call the error handler. That's some kind of problem. We don't really know what it is, but we'll just do that. So now if you would, can we run it?
Just run?
I think. Hey! There we go.
That is a web browser.
We built a web browser?
That's awesome.
Can we get the... will they pay us all the IE team salaries if we can just ship this? No, maybe not. Okay, great. So, yeah, that's our promises. So can you switch me back? So one of the cool things about promises versus callback functions is they actually give you an instance that you can pass around without knowing what you're going to do with it yet. And so here you can see myXHR. We ended up calling it something different in the demo, but here you can see myXHR. You pass it a URL, and then you get an object back. And you don't have to know right now what you're going to do with that object. In this case, I do, but you could return that from a function. You could stick that on the global object. You could do whatever you want with it, and at some later date, you could call then on it. And then they compose. So here we call then on the result, and we get the result of URL1. And then we can call something else, because maybe that contains some information we had to parse out of it. And so then we call return myXHR of URL2. That then returns another promise. And that other promise we can then get data out of, and then we can do my URL3, myXHR of URL3. And so you can build these complicated chains like you would in synchronous code. In synchronous code, you call A and you get its result, and then you call B with that, and then you get its result, and then you call C with that, and finally you take that result and you hand it to somebody. Here, what you can do is you can hand the promise that is the result of this whole chain of operations to somebody, and they can just get that result when it's eventually available. One of the pro tips here is people frequently, when they're first encountering promises, forget the return. And so if you forget either of these bolded returns here, what ends up happening is the next method in the chain will execute synchronously, just immediately, because it's as if you returned undefined. And so what ends up happening is you don't actually get what you expect on a number of levels. You don't get the blocking, and you don't get the value. Now, as I said in the last slide, the success handler of the chained promise gets the result of executing the prior success handler in the chain. There's also an error handler, and we don't see that in either of these cases here, but you could have said comma in either of these ends and included an error handler, and that would handle an error that had propagated through that chain.
That's because web requests never fail.
It's true.
The internet is infallible.
Perfect networks.
Yes.
The internet is infallible. As I said, remember the return. And the beauty of this is it allows orchestrating really complicated asynchronous processes. Not that you want that, but you kind of sometimes you have to. And the other thing is errors from the entire chain can be handled in one place. And so the way I think about this in synchronous terms is like try-catch.
Oh, and the cancellation, actually, also.
And cancellation.
You can take that result of that whole big then with the error handlers and all the ors.
Cancel them all.
And just say cancel that, and the whole thing, all the work gets terminated. And
finds its way up
through
to the one that's currently executing, and they all get terminated. And so here at the bottom, you can see an example where I say p.then of s1. I take the result of that and call then of s2. And then at the very end, I call then, and I say, oh, I don't need a complete handler, but what I'm going to do is have this error handler, and that will handle any error that happened along the way. And so it's a great place to put logging and things like that. So the thing we just saw a minute ago works like this. So one of the things you can do is you can chain a long list of operations, and then in terms of time to execution, they get into blocking. So one runs, and then the next runs, and then the next runs, and then the next runs. And for instance, if you had data-driven stuff, so I will say, I'm just going to browse through these. These are definitely, some of these slides are going to hurt your head, but you can look at them offline. They hurt my head anyway. But you can like say, hey, I'm going to take a list of URLs, and I'm going to reduce them into XHRs for each URL. But I'm going to chain them together so that it does the first one, and then it does the second one, and then it does the third one, and then it does the fourth one. And so the time to total completion is the sum of all those times. But you can also build really interesting composing.
This one's not interesting.
This
is so straightforward.
Thank you, Chris. But you can also build other interesting composition mechanisms like joining. So in this example, you can see, hey, I have 4 different tasks. They take 4 different periods of time. I want to start them all at once because I have a mechanism to have them parallel. Even though I can only run one UI thread, in the background when you do XHR, that's actually running on other worker threads. You do things in the WinRT like file I/O, that's running on other worker threads. And so even though you can't run your JavaScript there, that doesn't mean the system can't take advantage of those CPUs. But you say, hey, I'm not ready to do anything until all those things come back. And so here's an example of that. And we use promise.join. And what you give it is either an array or an object. If you give it an array, it basically enumerates through the entire array saying, oh, I'm not going to be done until all these promises are done. And if any of the promises turn into error, then I'll finish with an error. If it's an object, it uses object.keys to kind of do the same thing. one kind of cute trick is if you have a set of these things that you want to complete, but you want to complete them in a well-defined order. So for instance, you have a UI and you want to have that kind of top left to bottom right effect of items coming into the UI. And so even though it may be the quickest thing that you're doing is getting that one at the bottom right corner, you don't want it to show up until all the other ones to the left and to the top of it are done. Then you can use this next trick to build something that kind of has this waterfalling semantic. So even though task 3 took a shorter period of time than any of the others to complete, it blocked on the next one running. And so like, you know,
wait. I just want people to look at this for just a moment and see how long it takes somebody to figure out how this works. Yeah, we can't wait any longer.
All right, great. So anyway, but
it's awesome code.
These are the kinds of things that you can build. And the nice thing is, in general, you can actually build these once on top of a piece of functionality. And so like right here in the middle, do I have a laser pointer on this? Right here in the middle, you have my XHR URL. Well, of course, you could put any old function there. And so you could actually build this in kind of a templated way where you say, I now know how to build the top left to bottom right, thingy. And the way it works is I join on the previous one every time, and that's the thing that blocks me. And now I never have to write that again. And
well, in fact, this is how join is written.
In some sense, this is how join is written.
So people always ask for different compositors, like, can you give me, when the first one completes, return its result, then cancel other work? Kind of a at most one, or at least one. There's all these different verbs. And so you can create these functions and then just whack them in, and then you can just build your own compositors, similar to what we do with promise.join.
It's pretty cool. So unfortunately, as I said in the beginning of this section, promises are one of those things that start off really easy and get complicated really fast, just like asynchrony in general. Error handling is one of those places. So there's two continuation methods on the promises. There's then, and that's the one we've seen so far, and it yields a new promise, and that promise is for the result of the completed or error handler that's inside of it. There's another one that we provided that's done. Done yields nothing. And you say, well, why would I want done to yield nothing? Well, the reason you want done to yield nothing is done is a statement to the system that this promise chain no longer continues. And because of that statement you've made to the system, now the system can say, okay, any error that exists at this point in the promise chain is terminal. And in fact, we're going to crash your app. And so it's a statement to the system that, hey, I wrote this code and it should be right. There shouldn't be any error here, so now you can debug it and figure out what's going on. Unfortunately, the then promises, because of the nature of that beast, you can never really know when they're done. Because you could take a promise that comes out of a then, you could stick it in a global object, and you could come back 2 days from now and subscribe a then to it that handles the error. And so done is kind of that required mechanism for doing that. Asynchronous error handling and finding asynchronous errors are very hard. My recommendation is logging. Logging is your friend. You put a lot of logging in your async stuff, and that will help you get a lot further.
And there's a utility, WinJS.log, built into the framework, which kind of is just an extensible point for outputting console messages and things like that. So it's very easy to tack that in and then make it conditional so that you can turn your logging on and off.
Yeah. And so then the other thing is, and this just from personal experience, I found that there are plenty of times when you want to catch an exception and it popped up somewhere in your code and you'll want to find this line in base.js. You'll find plenty of people on the web complaining about this. Line 16, 14, memorize it, put a breakpoint there. It'll help you. So real quick, the other nice thing here is the Visual Studio exceptions dialog. I just want to really quickly just show you that. And so if we go back to...
Go back to our code real quick.
Go back to our code real quick, which Chris conveniently crashed or eliminated. And so now in here, if I say just winjs.promise.timeout, so promise.timeout is just a mechanism to say, hey, I want this thing to complete sometime in the future. And he says promise.timeout.then, and then inside this function he throws an exception. So this is an asynchronously occurring error. And then at the end he says .done, .dine, you're going to eat it. And so then your app will terminate. We have a nice little comment here saying go to this link. We have some documentation. This is
but you see my call is nowhere to be found.
But you see the call is nowhere to be found because we actually went and we waited some period of time and we're being called back from the event loop. And so the trick here is anytime you end up here, my advice to you, anytime you end up at this comment right here, the first thing you should do is go up to the debug menu and you should go to the exceptions dialog and you should click thrown exceptions for JavaScript and rerun your app. And now you will see this site right here. Now, it may be the case that your app has exceptions that it throws and catches, and so this can be a little noisy, and you have to be careful about using this all the time. But it's an invaluable resource in the event that you are scratching your head for a while. Great, so that was promises. And our last section for today is data binding. And so this is my personal favorite section today. I wanted to get up on stage and talk about data binding, and we'll have a little treat in there. But so here is our data binding system that we built today. And let me just kind of start by explaining this to you, and then we'll talk about some of the intricacies. So we have a little piece of HTML at the top, which is this div. And that div has an ID. And that div has a data win bind attribute. So we didn't talk much about our declarative processing today. But WinJS is both an imperative framework where you can say, we have a control model where you can say new list view and things like that. And we also provide a declarative piece to that. And that's to enable tooling and just writing down HTML. We provide some helpers that will go and find all these data dash attributes and instantiate whatever they declare. In this particular case, we're using the data dash attribute to say data dash win bind, and we're specifying a binding, data binding that should occur. And this is a little syntax that we have a little parser written that deals with this. And what it says is style.background color, bind that to color. And one of the first things I want you to notice here is this doesn't look like a CSS property. In CSS, background color has a dash in it, and the C is lowercase. This looks like a JavaScript property. And that's, in fact, what our data binding system is doing. It's actually basically a declarative way of specifying JavaScript property sets. And so here we're setting the style.background color, and that's kind of the code that you might have written in JavaScript, except using equals instead of colon. And then in text content, we're setting the text content of the div to the text. Now you ask, where is that data coming from? Well, we go down to our script block, which obviously we wouldn't put in a script block. We put in a JS file, right?
Of course.
Of course. And here you can see we have a data object. Now, the interesting thing to note about the data object is it's not just a JavaScript object. There is a proposal for ES6, the next version of JavaScript that's being worked on by the ECMAScript committee, to add this thing called observable objects. Pretty cool feature. And in the event that that ends up becoming a standard, we can imagine that it's very similar in desire to what we've built here, which is basically an observable wrapper over JavaScript objects. And the way we built ours is you call winjs.binding.as, and it gives you back a proxy object. And as long as you write through that proxy object, notifications will be sent. And we have a mechanism to rendezvous on that thing throughout our data binding system. So the next thing we do is we call winjs.binding.processAll. So I mentioned earlier we have a mechanism to go and instantiate these declarative attributes. Well, this is how we instantiate the binding declarative attributes. We specify an element on which to do an element tree on which to do this declarative processing, and we specify the data context in which to bind it. And so then, lastly, just for fun in this video, or in this demo, we actually go and change the color. And so here you can see we have a set interval. It runs every second, and it goes and sets data.color to a color and just increments a counter and goes through this little array of colors. So there were great. Sorry, I lost my place for a second. So data binding, WinJS. So we talked about 2 of these 4 parts of data binding in WinJS in that last slide. One of those things is observable. So these are these proxy objects that we use winjs.binding.as to get access to those. The second thing is that declarative syntax for specifying data bindings. That's the data win bind attribute. The third thing, which we're not going to talk about in the talk today besides mentioning here, is winjs.binding.template. If you want to find out more about these, go see the list view talk later today. It's a great talk. But WinJS binding template allows you to specify a collection of data bindings and some HTML that's meant to be instantiated in a collection context. So a thing like a list view or a flip view, you build your own collection controls. A template is meant to be run over a list for each element of the list. Which brings us to the last thing, which is winjs.binding.list. So just like we built a observable proxy over WinJS objects, we built winjs.binding.list, which is kind of an observable a data array, a JavaScript array. And the distinction between it and a JavaScript array is simply that it offers up change notifications when you do and run push, or you go and run set add, or you do anything like that. The other cool thing about our data binding system is that we have an out built into the system from the beginning. And so we call it a binding initializer. So earlier in the slide that we saw here, you can see data win bind says style.background color, color, semicolon. That's a binding initialization statement. There's a third optional thing that can be there, which is after color you can have a space, and then you can specify a global name. So like a namespaced binding initializer of some kind. And that basically says run that code when it's time to do data binding. And we shipped a number of data binding initializers with the system. One of the ones we shipped is WinJS.binding.defaultBind, which does the same thing as doing nothing, and is there as a mechanism for you to build your own things on top of, so you can thunk back into the system. One of them is called WinJS.binding.OneTime, and that's for use with things like non-extensible objects. So if you have a non-extensible object, you won't actually be able to do live data bindings against it, and it doesn't matter because it won't change. And so that's how you do that there. WinJS.binding.setAttribute. So like I said before, the WinJS binding system is about setting JavaScript properties. Sometimes you actually want to reach into the HTML element and set an attribute. This is for doing that. And then lastly, just the one that puts the two together. So Chris, can we go write a binding converter? So one of the things people frequently want to do with data binding is they say, I've got a value and it's kind of one thing, and I want to turn it into a value that's another thing. So first, Chris is going to show us a
This is the app we were running that we showed before.
Yeah, sorry. This is the app that I showed that slide. And so you can see the set interval is running at a very high frequency and changing the color. So let's go and change this app. And the thing we're going to change is inside of model.color, instead of having model.color actually be a color that CSS recognizes when we set the background color, we're going to have it be a number. It's going to be our counter. Because, really in real life, this is like, some random piece of data about your data context, and you're just going to compute something from it. And so now we change the set interval, and all the set interval does now is it actually increments that number. And if we run it again, we'll see that nothing's happening. Because obviously CSS doesn't know anything about numbers. You stick a number in the color, it's just not going to do anything. So let's go write a binding converter that will turn that number into a color.
I conveniently have one ready.
Oh, great. You conveniently have one ready because we're probably running a little low on time.
It could be.
Okay, great. So,
like Julia Childs, I have one just waiting here for you.
Thank you. Do you have an omelet for me too?
I do.
Here you can see we say WinJS.binding.converter. And inside the binding converter, all we do is do the same code we were doing before, which is basically index into the array using a modulo of the length to get a number out. And so now we have to go change. Here we go. We have to go change our binding attribute to specify that we're using that thing. And let's go. And now it's working again.
Excellent.
Great. So now, since we're running low on time, we're just going to drill right into the next example, which is the thing I really want to build today. One of our most requested features in WinJS 1.0 so far has been two-way data binding. Lots of people have wanted two-way data binding. And so we want to show you here on stage a very simplistic version of two-way data binding that you can write with our binding initializers here today. And in fact, Chris has once again written it already for us. So here you can see the first thing that we do is we specify another public name inside of our namespace. And we specify a binding initializer. And that just tells the system, hey, this function is safe to be used in a declarative context. Now, the binding initializer takes kind of the parsed version of that binding expression. So it gets the source object and the destination object, and it gets an array representing the properties, so the dots along the path. And then the first thing we do in this case is we thunk back into default bind. So we say, let the binding system do what it's going to do to set up the data binding. And then all we do is we sign up. We know the destination thing is always an element because it's on the declarative. It's the thing that we define the data binding on. We sign up for its on-change handler. And so inside there, we go and we get the current value, and we go and we get the value that's in that destination. So this might be an input text box, for instance. We go and we see if they're different, and if they're different, we go set it back in our model. So Chris, I assume you also conveniently change the HTML?
No.
Oh, okay, great. We get to type that. So can you give me 2 input boxes? That's not going to help. Give me 2 text input boxes.
Great. 2 of them.
Yeah, 2 of them. And in both of them, give me a data bind. Oh, wow. You're using the cool kids tricks.
Well, you said put it on both.
I like that. Thank you. And so now we're going to bind to the value property of the input box, right? That's the JavaScript property with which you can reach into the text box and get its value or set its value. We're going to wire that up to our two-way data binding. We're going to run. And in theory now, we can change this, and it binds both ways. We can go to the other one. We can change it, and it binds back. Now, of course, the thing to realize, of course, we wrote the simplest two-way data binding we could write here on stage. Chris wrote it, as I spoke, I guess. And in this model, we didn't hook all the events that you'd really want to hook to get this right. You'd want to hook key press. Right now we only hook change, which the HTML platform says happens when focus changes, and so that's why you saw only when Chris pressed tab did things commit, things like that. We also didn't handle lots of dots in here. Chris took the easy way out on the source prop sub-0 and things like that. And so there's some more work you'd want to put in here, but it's a very powerful mechanism to extend our data binding system. So should we plow through?
No, you just talk to what we're going to show.
All right,
here.
great. You're just going to keep on typing then.
That's my goal.
Okay, thank you. So lists. One of the other things that we talked about was lists. So frequently you want to be able to take an array, and you want to be able to add items to it, you want to be able to remove items from it, and you want to get live updates from that, and you want to see it inside of a list view. And so Chris, why don't you bring up an app, and here you can see a list view.
It's a very exciting list view.
It's a very exciting list view.
We can add numbers to it.
You can add numbers to it. You can add random numbers to it.
We can add lots of numbers at once.
And now if we
One of these was Nan.
It's because you got space in there.
Oh, that's what happens when you do the...
So if you go look at the code for this, this is the interesting part, or somewhat interesting part. All we had to do was we used this data win control attribute to declare that we have a list view, and in its options we wired it up to the binding list. And if we go look at the code, we'll see that demo.items is this binding list thing, which just happens to shoot change notifications off of it, and the list view knows how to consume those things. All we had to do was construct a binding list, and we can give it some data when we construct it. And then just like an array, we just call push, push, push. And so you can see here, add 10 just calls push in a loop, and then the list view just updates. One of the cool things that we can do with binding lists is we can have things called projections. And so the projections, what they do is they take a binding list and they give you a live view over the top of that binding list. And so we have 3 different projections in the system. We have filtering, sorting, and grouping. And so like the filtering one, you can give it a predicate and you say, hey, all of the numbers that are odd, those should be in my filter. And so when you add new items to the collection, if they're odd, they show up in the filter, and if they're even, they just don't show up. It's as if nothing happened. And it's pretty cool that they end up keeping live over the collection. So let's real quick go and take our list of data and let's group it.
Probably one of the most common things people do is that default Windows personality is these grouped items.
Yes.
And so being able to do that dynamically on the fly without having to munge your data ahead of time
is pretty
convenient. So great. So I think the first thing we need to do is we're going to create a projection on top of this thing. And so we're going to do that by saying demo.items.create grouped, which is the projection we're talking about here.
And we end up giving the grouped guy 2 different functions. Now, in our particular case, these 2 functions are going to be the same. Frequently, in real-world apps, they're different. One of them has to return a string, and that's the key that represents the group, and it's stable over time. So for a given data item in the group, you have to be able to determine what group it lives in. So people will do this either by having their data model have a group hanging off the items, or they'll be able to infer it from their item like we can here. We can just do some math. And in this particular case, we're going to use the same function for the group data. This is the thing that's passed to the group header that gets rendered. In our case, it's just going to be odd or even. In a lot of cases, it's actually some complicated group data because you're going to render like pictures and all kinds of cool stuff. So that's all we have to do is go and change this to create this grouped list. And now we have one more thing we have to do in the HTML, which is we have to change the data source. So there's 2 data sources you can set on the list view. One is called the items data source, and that's like that main set of items. And then the other one's the group data source. Now, conveniently, the binding list, when you group it, puts both of those things together. In demo.results.dataSource is the items, and then it has a groups property hanging off it, which is also a binding list. And so we can wire those 2 things up. And in theory, when we hit F5, we now see odd and even items. And if we add an item, it goes in there. If we add that, it goes there. If you add an odd one, it goes there. If you add 10, they just show up. And that's all we had to do to create grouped data in our system. And you can similarly create filtered data, you can create sorted data, and you can even stack these things. So you can say, oh, well, I've got a list of data, and I want to group all the men. So I'm going to do a filter that takes all the men, and then I'll do a group on top of that for first letter or first name or something like that.
So wait, I can just do this? We got 1 more second, so I can say create sorted.
In theory, you have to give it a sorter.
Do I have to give it a sorter, or is it going to default?
I believe you have to give it a sorter.
Oh, that's going to take too long.
No, you can do it. You can do it. Function of A, comma B, return A minus B. I may have this backwards. I don't know. There you go.
And we can see they fill in the little holes. And this is getting that list view animation by default.
Yeah, so the list view is doing the heavy lifting here. So like there's multiple layers, of course, and at the bottom layer, the binding list is maintaining the data source in its appropriately shaped form, and then the list view is doing an enormous amount of work when Chris just leans on the 10 random there like that, and there's probably a lot of animations going on in the background that are getting canceled and what have you, but eventually you end up with this list view, and it's running under the debugger a little bit slower than normal, but still it's running pretty great.
Great.
Thank you, CodeMonkey. All right.
Ooh.
So that's all I got. So I recommend going and there's some great sessions to watch that happened over the last couple days. Chris and I did an intro to WinJS session that covered some different stuff on Tuesday that's interesting. There's a couple great talks today. There's a talk at 4:15 on modern JavaScript, so writing great JavaScript code. There's a talk today at 2:30, which is a deep dive into list view, where a guy on my team, Mike Mass, is going to build a really, really cool list view with its great peak animation and all kinds of cool stuff.
Better than ours?
Better than ours.
Oh.
Dramatically better than ours. But yeah, so
I think we have time for about 2 questions.
Do we have time for 2 questions? Is that it?
Right up here.
So with the two-way binding, how do you make sure you don't get into a circular binding?
So the way that you make sure in this case that we didn't get into, the simplest way we made sure we didn't get into a two-way binding loop was just by checking that the values were different. And say, oh, well, if it's the same value, we're not going to set it again. But in a real hardcore, non-demo two-way binding implementation, there would be a number of things you'd need to do, which would take longer than I can talk about here.
Yeah.
But yes, two-way binding is currently an exercise for the
Question in the aisle right there.
Yes, I have less of a question, more of a statement, which is I'd like to thank Josh personally for building the binding list.
Oh, you're welcome, Mr. Sells.
That piece of magic he built, and in fact internally it's called Josh's list.
No longer. We used to call it that.
Yeah, and he built it because some whiny PM on the templates team came to him and said, I can't build apps the way I want to.
That wine sounds familiar right now, Mr. Sells.
Yes.
Great. Thank you, sir. Any one last question? All the way over here on the right?
So back to the protocol thing, there doesn't seem to be any sort of authoritative source on saying who gets what protocol. What happens if something else registers the same protocol?
What happens if 2 people stomp on the same protocol? I don't know. We can go try it.
User gets the choice.
User gets the choice. We have from Mr. Brockschmidt, who literally wrote the book on this stuff. So
Well, I believe we have 2 authors. Of
we have
books on
2
this stuff
authors
in
here.
the-
Yes. One is available on PDF right now. The other, I think, you have to pay real money for.
Yes, and pre-order.
No, so user gets choice. There you go. Thank you very much. We're going to go across the way to the chat area on the far side by the on the right up there. So if you have any more questions, just come grab one of the 2 of us over there, and we'll chat more. Thank you. Thank you very much.